All right, in this video, we're going to be taking a look at the where's the horizon task. This is going to address question 2. So I've already looked at question 1 in a previous video. Feel free to fast forward to different parts that you're interested in. I'm going to be going sort of in order through the question. So this question says that our sort of sea level and horizon distance data can also be modeled by this function. Now this is a quadratic function, right? They're specifically saying that we're going to use this model, right? Not vertex form, refracted form. It says assume that when the height is 0, the distance to the horizon is 0. So this means that when the height is 0, the distance to the horizon is 0. So this is saying, right, that the point 0, 0 is part of the function. Is part of the function. So if I'm going to assume that, then I'm going to substitute 0 for x. And substitute 0 for y, right? Because I'm going to substitute the point 0, 0 into the equation. And this gives me a 0, this gives me 0, and this gives me c. So therefore c equals 0. Right? So you see how it says show that, right? I wanted to make sure that I did some sort of working that would help to finish with c equals 0 as my conclusion. So I need to translate this into a point. I'm going to substitute that point into the general equation for the quadratic. And when I substitute all of that in, I end up with c sort of simplifying to show that it's equal to 0. Okay? So I wouldn't use c equals 0 in any calculation. I want to finish with that as my conclusion. Now, when c equals 0, the model is y equals ax squared plus bx. So that's nice because I only need to find a and b. And it tells us to use the point 2, 5 to form an equation in a and b. So now, at first that might sound a little bit strange, but basically we remember that 2, 5 is just a simple point, right, in that set of data. So 2 would be x in this general equation, and 5 would be y in that general equation. So I'm going to put 5 in for y, 2 in for x, and I'm putting 2 in for x anytime that I see x. And then I'm going to simplify this equation. So that's 2 squared is 4. That's 2b, and then if I write that equation properly, it's 5 equals 4a plus 2b. All right, so that is an equation in a and b. It's an equation that only has the variables a and b. The next question says use the point 5a to come up with another equation in a and b. Well, I'm going to do exactly the same thing. This is x and y. 5, 8 is simply one more point in my data set. And so y is 8 equals a times 5 squared plus b times 5. Square the 5. And then, of course, write that properly. 8 equals 25a plus 5b. Again, that's an equation in a and b, which means that it only has the variables a and b in it, right? So I've made 2 equations, right? And I've got 2 unknowns. You probably are starting to guess what I'm going to need to do next. A good part of doing these modeling tasks is anticipating what we're going to be doing next, right? Solve the equations in part B and write down your model. So I had 5 equals 4a plus 2b, and 8 equals 25a plus 5b. Let me just check to make sure that that's what I had. Yes, indeed. There and there. So those are the equations that I had, right? And so what I'm going to do now is solve those. Now, I have my graphing calculator available to me, so I could do the algebraic method, which is elimination. Right, and so what I would probably do is multiply my equations so that this is times 5 and this is times 2. Because I'm noticing that my b coefficients are small, right? And so they're manageable. And so that would be me getting 25 equals, for equation 1, 20a plus 10b. And then times 2 all the way through to equation 2 would give me 16 equals 50a plus 10b. Okay, and then I could subtract my equations. I would get 9 equals negative 30a, and then these two would subtract away completely. And then I divide by my negative 30, and I'm going to get a equals 9 over negative 30. Or divide by 3, I'm going to get 3 over negative 10. Okay, or negative 0.3. Then I would use that to find b, and so on. Okay. Now what I'm going to show you is the graphing calculator method, just because if you're going to have your GDC throughout this whole task, imagine the amount of time that it just took me to do that. It's far better for me to use my GDC to solve that. Okay. And in order to do that, I'm going to need a graph screen. And then I'm going to, I guess the only problem is that I'm going to need to isolate one of my variables. So I'm going to need to manipulate equation 1 so that I subtract the 4a on the left side and then divide by 2. All right. And so then I'm going to type in 5 in brackets, 5 minus 4x divided by 2. Okay, so my a is going to be my x in my graphing calculator, and b is going to be my y in my graphing calculator. I'm going to have to try not to get mixed up with the definitions of x and y in my actual task. Okay, and then I rearrange this equation so that it's a minus 25a, 8 minus 25a, and then divided by 5. So I'm going to graph that in brackets. 8 minus 25x, excuse me, right? And then divided by 5. And I've got 2 lines that intersect. And then in order to do that, I'm going to go to my menu and select Analyze Graph. Oops. And I'm going to choose intersection. With the graphing calculator, press Enter. The graphing calculator is going to do is it's going to ask me for a lower bound. So I'm going to just click to the left of the intersection point. I see the intersection point already right here, right? It doesn't really matter where I click as long as I click to the left of it. Now, it doesn't matter where I click as long as I click to the right of it. And you can see that I'm getting an intersection point, okay? So the intersection point is x is negative 0.3, which means that a is negative 0.3, and y, or b, is 3.1. Okay. Oops, excuse me. It told me to write down my model. Just look back at the question, and what's meant to go in the blank is actually the model. That's a good mistake to make while I'm doing a video, actually, because that's a very common thing. A common strategy is to make sure that we write down what they actually want. So my model was meant to be y equals ax squared plus bx. Yeah, remember that? And so therefore my model is negative 0.3x squared plus 3.1x. There's my model. There's my model. So that's from the graphing calculator working that we did there.